In this session, I'm going to introduce some common terminology in natural language processing. The first term is called corpus. In the domain of natural language processing, statistical NLP in particular, there is a need to train the model or algorithm with lots of data. For this purpose, researchers have assembled many text corpus. Typically, each text corpus is a collection of text sources. There are thousands of such corpus for a variety of NLP tasks. While English have many corpus, other natural languages have their own corpus as well, though not as extensive as those for English. Using modern techniques, it is possible to apply NLP on low-resource languages, that is, languages with limited text corpus. Then we have stemming and lemmatization. For grammatical reasons, documents are going to use different forms of a word, such as organize, organizes, and organizing. Additionally, there are families of derivationally related words with similar meanings, such as democracy, democratic, and democratization. The goal of both stemming and lemmatization is to reduce inflectional forms or sometimes derivationally related forms of a word to a common base form. Stemming usually refers to a crude heuristic process that chops off the ends of the words in the hope to achieve this goal correctly most of the time, and often includes the removal of derivational affixes. Lemmatization usually refers to doing things properly with the use of a vocabulary and morphological analysis of words, normally aiming to remove inflectional ending only and to return the base or dictionary form of a word, which is known as the lemma. The next NLP term is called tokenization. Tokenization is a common task in natural language processing. It's a fundamental step in both traditional NLP methods like count vectorizer and advanced deep learning-based architectures like transformers. Tokenization is a way of separating a piece of text into smaller units called tokens. Here, tokens can be either words, characters, or subwords. Hence, tokenization can be broadly classified into three types: word, character, and subword. As tokens are the building blocks of natural language, the most common way of processing the raw text happens at the token level. For example, transformer-based model, the state-of-the-art deep learning architectures in NLP, process the raw text at the token level. Similarly, the most popular deep learning architectures for NLP like RNN, GRU, or LSTM also process the raw text at the token level. And then we will talk about stop words. When we are pre-processing the raw text data, we need to be careful with stop words. So what are stop words? In computing, stop words are words that are filtered out before or after the natural language data are processed. Stop words typically refer to the most common words in a language. They are the words in any language which does not add much meanings to a sentence. They can safely be ignored without sacrificing the meaning of the sentence. For some search engines, these are some of the most common short function words, such as der, is, at, which, and on. In this case, stop words can cause problems when searching for phrases that include them, particularly in names such as the who or take that. If we have a task of text classification or sentiment analysis, then we should remove stop words as they don't provide any information to our model, such as keeping out unwanted words out of our corpus. But if we have the task of language translation, then stop words are useful, as they have to be translated along with other words. Then we have bag of words, which is a modeling technique to represent text data with machine learning algorithms. The approach is very simple and flexible, and can be used in various ways for extracting features from documents. A bag of words model is a representation of text that describes the occurrence of words within a document. It is called a bag of words because any information about the order or structure of words in the document is discarded. The model is only concerned about whether known words occur in the document, not where in the document. The intuition is that documents are similar if they have similar content. Furthermore, that forms the content alone, we can learn something about the meaning of the document. The next term is called normalization. Normalization is the process of converting a token into its base form. In the normalization process, the inflectional form of a word is removed so that the base form can be obtained. When we want to analyze text, the analysis process can be much more accurate if the text we are using is in a standard format. Putting the text in a standard format is so-called normalization. For example, the entire text should be in upper or lowercase, or we should convert US, USA, America to US. Normalization is helpful in reducing the number of unique tokens present in the text, removing the variations in the text, and also cleaning the text by removing redundant information. Then we have part-of-speech tagging, which is a popular NLP process, refers to categorizing words in a corpus in correspondence with a particular part of speech, depending on the definition of the word and its context. Within a sentence, each word has their part of speech, such as verb, noun, adjective, etc. POS tagging can assign a specific tag to a word. POS tagging are useful for building parse trees, which are used in building NER. Most named entities are nouns, or extracting relations between words. POS tagging is also essential for building lemmatizers, which are used to reduce a word to its root form. One important concept in NLP is called word embedding. Word embedding are a type of a word representation that allows words with similar meaning to have a similar representation. They are a distributed representation for text that is perhaps one of the key breakthroughs for the impressive performance of deep learning methods on challenging natural language processing problems. Word embeddings are in fact a class of techniques where individual words are represented as real value vectors in a predefined vector space. Each word is mapped to one vector, and the vector values are learned in a way that resembles a neural network, and hence the technique is often lumped into the field of deep learning. Each word is represented by a real value vector, often tens or hundreds of dimensions. This is contrasted to the thousands or millions of dimensions required for sparse word representation, such as bag of words. We will talk more about web embeddings in the later slides. Last but not least, we should also understand n-grams. In the field of computational linguistics and probability, an n-gram is a continuous sequence of n words from a given sample of text or speech. A phrase with 2 words is called bigram. A phrase with 3 words is called trigram. And why do we want to use n-grams? In NLP, n-grams are used for a variety of things. First of all, it can help in deciding which n-gram can be trunked together to form single entities, like San Francisco, trunked together as one word, high school being trunked as one word. It can also help make next word prediction. Say you have a partial sentence, please hand over your. Then it is more likely that the next word is going to be test or assignment or paper. Then the next word being school. It can also help to make spelling error corrections. For instance, the sentence drink coffee could be corrected to drink coffee if you know that the word coffee have a high probability of occurring under the word drink, and also the overlap of letters between coffee and coffee is high. Basically, an n-gram model predicts the occurrence of a word based on the occurrence of its n-1 previous words.